Good evening, sir.
Good evening. Hello, everyone. Good evening. Am I audible clearly to all of you?
Yes, sir.
Okay. So in 2 minutes, we're gonna start the class, right? Uh, Shri, beta, in the previous class, that thermal expansion questions we have done now, PYQ questions,
Yes, sir.
and some of the question I have given in the PDF.
Yes, sir.
Okay. All right.
Sir, I have one doubt from there. The first one with percentage change in mass density.
Can you just send that question to me on WhatsApp after the class? I'll
Yes, sir.
give a
Yes, sir.
voice note. Okay.
Thank you, sir.
Huh. Any one of you have any doubt, you can take my number from the group. Okay. Utkarsh Rai name will be written. Save that number. Anytime you want to discuss any kind of question, you can just send it to me. Good evening to everyone. So let me share the whiteboard. All right, everyone. So after thermal expansion, the next topic that I'm going to start now, and let me give you a clarity about how we're gonna proceed in physics. Okay. So as of now, I was handling only one part, but now I think the first part of the physics, that is the mechanics part, also I have to take. So, guys, I want to discuss two topics before I move to the motion in 2D and afterwards what you have done. Calorimetry and heat transfer. These two topics I want to finish in heat and thermo. Then I will stop this unit and we will do thermodynamics, which is totally a different chapter. Ideal gas behavior or ideal gas equations and kinetic theory of gas. These three chapters are interlinked. These part we will do later. So these two topics I'm going to finish within by the next week. So are we clear with our uh, proceedings, how we're going to proceed in physics? And could you anyone let me know that what was the last topic done in the first part of the physics? Motion in 2D, relative motion, what was that?
So we finished with motion on inclined plane, projectile motion.
Okay, so projectile motion was done, right?
Yes, sir.
That part is clear to everyone, inclined projectile motion, or some of you have doubts? If it is clear, then what I will do, I will start from laws of motion. If it is not clear, then I will take one or two lecture on inclined projectile motion. Then I will proceed to laws of motion. But it will totally depend on you guys.
Sir, can we do relative motion first as it was not discussed in class?
Relative motion was also not discussed. Relative motion in 2D.
Yes, sir.
Means rain problems, river problems, all those things which comes under 2D.
Yeah, those were not properly discussed.
Okay. All right. So fine. I got it. All right. So relative motion I'm going to discuss. Inclined projectile motion I was talking about. Are you guys comfortable with inclined projectile motion problems?
Could you discuss it a little bit?
I will do. So I'll do one thing. Okay. Let's do it in that way. When after finishing these two topics now, inclined projectile, I will take some PYQs and we will discuss in the class. And those will be the JEE Advanced and JEE Mains question. If you are comfortable, you will give me the answer. If you're not, then I will discuss the solution in the class itself. Is that clear to everyone?
Yeah.
And
Yes.
once we're done with that, I will take the relative motion in 2D. Got it? And then we will proceed towards laws of motion. Is that clear to everyone?
Yes, sir.
Yes.
All right. So let us start this topic called calorimetry. Have you heard about calorie anywhere? It's a very common and famous term, right?
Yes,
In
sir.
every food packet, if you see, or something which you can eat, they have written how many calories it contains, right? So in calorimetry or calorie, first I will introduce calorie. Calorie is a unit of heat or unit of energy. Till now, you know the unit of energy as joule. Calorie is also unit of energy. And 1 calorie, some of you may know it, but let us, 1 calorie is equivalent to how many joules? 4.18 joules. So whenever you have to convert calorie into joule, you have to take this conversion. Clear? So what we're going to discuss in this chapter, calorimetry, it's a very basic chapter, but an important one. In calorimetry, we're going to discuss the amount of heat required to heat any material on any body. Is that clear? Now, when we heat a body, two things may happen. The first thing is the temperature of the body will rise. So if there is a body and you are giving heat to the body, so I will represent heat by Q. This is a heat energy. So I'm giving heat energy to the body. So what will happen? Either the temperature will rise or phase will change. Now, guys, just think about it. If we have a ice, right now you don't know anything, but obviously common sense is there, so we can answer based on that. You have a ice at 10 degree and you start giving heat to it. What will happen? The ice will immediately start melting, or it will first rise up to a certain temperature, then it will melt.
Sir, it
So
will
first it will rise to
up
0
to a
degrees
certain
Celsius
temperature.
and then melt.
Yes, it will rise to a temperature which at a normal pressure we say that melting point temperature. So that temperature is how much? I'm sure everyone knows it. 0 degree. So from -10, the temperature will rise first up to 0 degree. At 0 degree, what will happen? The temperature rise will stop and it will melt into water. So this ice will first convert into water. This process is called melting. Obviously, while melting also it will take heat, right? But that heat is not going in rise in temperature. So that's why whatever heat we will give here, we will call that heat by a name latent heat. Do you know what is the meaning of latent? Latent means invisible. Why it is called latent heat? Because rise in temperature is visible on thermometer. But when melting is taking place, actually the bonds are breaking. The solid bonds are breaking and it is converting into liquid. So for that you are giving heat, but that heat is not visible in on temperature scale. Why? Because ice is melting into water at 0 degrees Celsius. So that's why this heat is called latent heat. Now, once it all converted into water, what will happen? It will again rise up to what temperature?
100
Because
degrees Celsius.
100 degrees
100
Celsius.
degrees Celsius.
And at 100 degrees Celsius, I'm sure all of you have guessed it, it will start boiling. It will convert into vapor. And obviously, if we keep heating, it will convert into superheat and all, super steam. That is different thing, but this is the general process that we have to follow. Now, the calculation of heat involved in this whole process is called calorimetry.
Excuse me, sir.
Himanshu, your mic is on. Do you want to ask something?
Yes, sir.
Tell me.
Sir, can you please again tell what is latent heat?
Yeah, sure. Why not? What I said, Himanshu, that when we are heating ice at -10, we are giving heat and the temperature scale shows the rise in temperature, right?
Yes,
So
sir.
that heat is visible on the temperature scale. But when you give heat here or heat here during melting or boiling, your temperature will stick up to a certain value until all water boils into vapor or all ice melts into water. So these heat are not visible on temperature scale. So that's why they are called latent heat, invisible heat. Here we are using heat for melting. So this is called latent heat of fusion. And here this heat is used for boiling. So this is called latent heat of vaporization. Is that clear to you, Himanshu?
Yes, sir.
Okay. So just like Himanshu, if any one of you have any problem while the topic is going on, you can just raise your hand and or unmute yourself to ask. Are we clear with this, guys?
Yes, sir.
All
Yes,
right.
sir.
So we will use our method of, if we are clear, then give me a thumbs up sign, right? Okay. Let us come to the basic part. We will discuss about latent heat and change in the phase, but first we will discuss about rise in temperature. Okay. So we have a body. It have some mass. So obviously the mass of the body will be represented by M. Now I'm giving heat. Just use your logic and tell me. If I have 1 kg of body and if I have 10 kg of body, same type of body, okay, same material, 1 kg and 10 kg. And we want to rise up to certain temperature, that rise in temperature is also same. Which body will require more heat?
The
With the
one
10
which
kg
weighs 10
one.
The
kg.
heavier.
The one with the
Yes.
higher mass?
Yes, sir.
It makes sense, na? So the first point we will rise, heat, Q is the heat energy, is directly proportional to mass of the body. More the mass, more the heat required. Are we clear with this?
Yes, sir.
Okay.
Yes.
Now, I will take very basic examples to make you understand these formulas. Now, I have two bodies of same mass, same material. And one I have to rise only by 1 degree and the other I want to rise by 10 degree, which will require more heat.
The one which
Second
will
one.
Second one
10
with
10 degrees.
delta T 10 degrees.
Actually, the one with more rise in temperature. So the second point is our heat is directly proportional to rise in temperature, delta T. Actually, we are giving heat, so we are calling it rise of temperature. If we take heat, it will become drop in temperature. Okay. Now, if we combine these two, and if we remove the proportionality sign, we can write the formula as ms delta T. Here S is called specific heat capacity. What is specific heat capacity? It is very important to understand. First of all, it depends on body, material of the body. It depends on the material of body, right? If there is a water, if it is 1 gram or 1 liter or 1 milliliter, it doesn't matter. Water will have same specific heat, right? So specific heat only depends on the nature of the material. If you have steel, whether you take 1 kg of steel or 10 kg of steel, specific heat will remain same. So specific heat depends on the material of the body. Obviously, mass and delta T factor we have already discussed. So these three factors depends on which our heat energy depends on. Can you tell me, guys, in the chat box, what is the unit of specific heat we will take? Because many times in unit dimension, they ask this question. It's very easy. Specific heat will become what? Q upon M delta T. Okay. So definition wise, we can say it is heat required how we write the definition? See, heat required to raise per unit mass per unit delta T. So heat required will be in which unit? It will be in joule, and mass will be in kg, and temperature will be in Kelvin. So this will be your unit. Joule, kg inverse, Kelvin inverse. Are we clear with this? All of you?
Yes, sir.
Yes.
Now, I'll tell you one thing. In our,
Sir,
In-
excuse me.
yeah, beta, tell me.
Sir, can't we write it as in calorie?
Yeah, I'm going to tell you that only. We can. As I said, calorie is a very important unit for us. Specific heat of water, which we're going to use maximum time. Specific heat of water is equals to 1.48 joule per gram per Kelvin, or 1.48 kilojoule per kg per Kelvin. I hope you understand how I'm changing this kilo in numerator and denominator without changing this value, right? Now, I already told you that 1 calorie is equivalent to 4.18 joule. So specific heat of water, you may see in many questions it's given like this. 1 calorie per gram per Kelvin, or not even Kelvin, it will be in degree Celsius. Is that point clear to all of you? How I have converted this? How this conversion took place? Because 1 calorie is equivalent to what?
4.18 joule.
4.18 joule. So whenever calorie is given to us, we will calculate all the heat in calorie, and at the last, we will convert it into joule if required. Is this point clear to all of you? Please give me a thumbs up on this, on the specific heat, because that is the.
Why doesn't like the value for Kelvin and Celsius interchange like some?
Abhijit, just one sec, but I'll take you out. Yeah, what you said, why?
Why isn't the value of in degree Celsius why isn't changing from Kelvin? The
Yeah,
magnitude.
on the scale of Kelvin or degree Celsius, now, whenever you take delta T in Kelvin and delta T in degree Celsius is same. We have discussed this part when we were doing the temperature scale, right?
Yes, sir.
So for heat calculation, we took T or delta T. We take delta T, right? So that's why it doesn't matter if you take change in temperature in degree Celsius or change in temperature in Kelvin. If there is absolute temperature, then obviously you have to put in Kelvin. Then we can't put it in degree Celsius. Then the answer will change. But since we are using delta T, change in temperature or rise in temperature, that's why it doesn't make any difference if you take the delta T in degree Celsius or Kelvin. Is that clear? But standard unit is Kelvin only.
Yes, sir.
Okay. All right, everyone. So let's start with a very basic question. Achha, there is a principle of calorimetry. Let me discuss that also. Then we will come to the part where we will start doing the questions. A calorimetry or a calorimeter is a insulated device. It's like a thermos where nothing is going in and nothing is coming out. So it's like this, a flask, you can say, where this part is insulated from surrounding. So whatever we are doing, whatever mixing we are doing, whole mixing is taking place inside the container. So net exchange of heat from surrounding equals to 0. So what we can say is gain of heat by liquid one. Suppose we have mixed two liquids together inside calorimeter. should be equals to loss of heat by liquid 2. Is that part clear to all of you? That if we mix two liquids inside a calorimeter, since no heat is coming out or going in, so their net heat exchange must be 0. Is that part clear to all of you? This is called principle of calorimetry. Obviously I will take some examples to make you understand this, but is that part is making sense? That if we are mixing two or more liquid and no heat is going out or coming in, so then whatever they are exchanged, it will be between them only. So obviously one will lose and one will win. Overall, it's a zero-sum game. Is that point clear to everyone? If it is clear, please give me a thumbs up.
So 0 means with the surrounding, the net exchange is 0.
Yeah, with the surrounding, the exchange is 0.
Okay.
Means surrounding is neither giving any heat nor taking any heat. Okay. All of
Sir.
you are clear? Yes. Who's that? Anyone?
Sir.
Yeah.
Sir, what is written after loss of heat by liquid?
Himanshu, could you please repeat what you said?
Sir, what is written after loss of heat by liquid? What is the symbol?
Acha, symbol. Loss of heat by liquid 2. Actually, I said that we are mixing two liquids, liquid 1 and liquid 2. You got it?
Yes, sir.
That was the doubt. Okay. Sorry. All right. Let us start with a very basic question and then slowly we will increase the. Try out this question.
So I'm not getting the option to send the chat personally. Will I send the answer directly here?
There is no option. Actually, in last meeting, they were getting. If you go in new chats, maybe you get the option.
So there is a option like above
sir.
where the
Got it.
pencil like icon is appearing.
Yeah. I think if you use that, you can send me personally. I think they have updated this chat thing. Yeah, now I'm getting it personally. Shri, correct, beta? Isabel, correct. Others also, I'm expecting answers very soon. Himanshu, just check your answer. Yeah, Anja, fine. Bhavesh, fine. Himanshu, the number of zeros, I think you missed.
Sir, even I'm not able to send you chat.
Aditya, in
I
chat
mean-
option, if you see that there is some icon made at the top.
Yes, started new chat.
Yeah, that if you use that, you'll send it.
Okay, yeah.
Yeah, got it. Gaurangi, correct. Okay, let me take this now. So here, the first thing is, since the unit is Aditya, correct, beta. First of all, you have to convert mass. Formula is very simple, m. But since we are using gram and degree Celsius, so degree Celsius is fine. Delta T doesn't matter, but mass should be in gram. So 5 into 10 to the power 3 into 1 into 80. So you'll get 4 into 10 to the power 5 calorie. Is that clear to everyone? Are we clear here?
Yes,
Himanshu, you got your mistake?
yes, sir, clear.
You didn't converted the mass in kg. Sorry, kg to gram.
Yes, sir.
All right. Let me take another question. Obviously, we will assume that all the mixing is taking place inside calorimeter. Solve it. Yash and Shri, correct. Others also, please send your answer first.
Done, sir.
Bhavesh, correct, beta. Anjia, could you please check your answer once? I'm giving just 1 minute for others to finish this question. Then I'll take it. Now, guys, here what you have to do is, since we have both same material, so we don't have to worry about the specific heat. Now, let me tell you a way where you can use the concept for any number of liquid given, not only two. What we will do is we will write like this: M1 S1 final temperature minus initial temperature. This is the heat exchanged by the first liquid plus M2 S2 final temperature minus initial temperature. This is the heat exchanged by the second liquid equals to 0. This is our principle now, that the net heat exchanged by all liquid, if we add, eventually we'll get 0. Is that clear to all of you? I know many of you have done like heat lost by the first liquid and heat gained by the second, sorry, heat lost by the liquid at 40 and heat gained by the liquid at 10 are equal. That is fine. But what if we have three liquids? Then how will you decide who will lose heat, who will gain heat, and what will happen to the one in the middle? So better we follow a method which is applicable for any number of liquids. Suppose if we have three liquid, you will write M1 S1 final minus initial, M2 S2 final minus initial, M3 S3 final minus initial equals to 0. Is that statement what I have written is clear to all of you?
So can you
Yes,
explain once why it is equal to 0? I didn't understand the equation.
Yeah, beta, sure, I will explain. Varangi, what I said is, suppose we are mixing two liquids, right? So M1 S1 final minus initial is the heat exchange, na? It is delta Q, right?
Yes, sir.
Delta Q1, and this is delta Q2. Now tell me one thing, if one liquid has received heat and one liquid has released heat, so can I say the net exchange of heat or total change in heat should be 0 because one has lose the heat and other one has gained it?
Yeah, okay.
Got the point?
Yes, sir.
Okay, all of you, now it's clear how we have written the statement. If it is clear, please give me a thumbs up. Then there is nothing else in the question. We'll just put the values and get the answer. Anyone having doubt? No. Okay. All right. So now let's put the values now. Luckily here we have both water. Later I will change it to other material. So 20 into specific heat of water. There's no need to put it. Final temperature we have to find. Initial is what? 10. 40 into specific heat of water. Final we have to find. Initial is 40. It's to 0. So we'll take this to other side. 40 into specific heat, final minus 40 equals to, minus will go inside. So 20 into specific heat. Because of the minus sign, it will become 10 minus T final. This and this is 2 times. So 2 TF minus 80 equals to minus TF. We'll take this to this side and this T final equals to 90. I'm sure, and some of you have already sent this answer. Final answer is 30 degree. Is this clear to everyone?
Sir,
Yes, Vita?
you took the mass in kilogram.
Yeah. Listen here. When I'm taking the ratio, suppose I'm canceling these two, right?
Yes,
As
sir.
long as both of them are in same unit, means if this is gram, this is gram, this is kilogram, this is kilogram, and we are canceling it, we don't have any problem. If one is in
Okay.
kilogram and one is in gram, then the problem will come. Getting my
Yes, sir.
point? Because we are cancelling,
Yes, sir.
so both should be in same unit.
Okay, sir.
Okay, let me now take a question which is slightly better than this one. Or else I'll just share the question with you all. Just wait. Can all of you see question number example 22.4? Is it visible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, all of you, please go for that question.
22.4.
Yeah, 22.4. 22.3 was a similar one what we have done. Use the concept what I just taught. Mass, specific heat, final temperature minus initial temperature. Add everyone equals to 0. Bhavesh, just yeah, what you're getting is perfect. Good. Bhavesh, you use the same approach which I just taught or something else? Bhavesh, am I audible?
So can you please repeat?
You use the same approach which I just taught or something else you have used?
Sir, I use the same.
Okay, good. Please others also get the answer. Actually, similar type of question asked, I think twice or thrice in JEE mains. Next class, I will share those questions with you all, the PYQs. Isabel, have you rounded off your temperature? Means final answer?
Yeah, sir, by very little.
Okay, you are getting in some fraction and then you're out of. Fine. Aditya, fine. Just last 1 minute. Others, please finish it, then I'll take it on the whiteboard.
Yes, sir. Just 1 or 2.
Yeah. Yeah, we can go, we can think in that way also. Shri, you're getting slightly away from the correct answer. All right, let me take it. So the question says that the temperature, let me take the question here. The temperature of equal masses of three liquid A, B, C, and the temperature are 12 degree, 19 degree, 28 degree. So they are saying when A and B are getting mixed, here the main thing is what you have to, Aditya, please listen carefully. Liquids are different. So different means their specific heat will be different. Is that clear? Only the masses are same. So when AB are getting mixed, what we will write? Final temperature is 16. Okay, this is T final. So we'll write mass of A, which is same, specific heat of A, final minus initial, plus mass of B, specific heat of B, final minus initial, equals to 0. Is that
Sir,
clear?
I thought it was same liquid, that's why I did like that. Right.
No. Clearly it was mentioned. I'll show you
Yeah.
the question. 3 different liquids. Okay. No issues.
Yeah.
You got the point.
Yeah.
Okay. So we'll solve it and we'll get 4SA equals to 3SB. This is the first equation we are getting. Now, what they are saying is, so basically, we are getting specific heat of B as 4/3 times specific heat of A. Then they are saying B and C are mixed together, and the final temperature was 23 degree. We will use the same logic. Mass is same, specific heat of B. Final temperature is 23 minus 19 plus mass into specific heat of C. Final temperature is 23 minus 28 equals to 0. Same thing we are using. So here we will write specific heat of B into 4 equals to 5 into specific heat of C. So we are getting specific heat of C equals to 4/5 times of specific heat of B. And specific heat of B is already, we have written 4/3 times of specific heat of A. So it will become 16/15 times of specific heat of A. Is that clear to all of you? What I have written on the whiteboard?
Yes.
Yes, sir.
Now, what they are saying is that when A and C will be mixed, what will be the final temperature? So again, same thing we will use. T final minus 12. Here I'll write specific heat of C. Mass into specific heat of C, final minus 28. So when you solve it, no issues, Shri, just check where you went wrong and try not to replicate
Yes,
it.
yes, sir, I got it.
Yeah. So here we'll say T final minus 28 equals to SA T final 12 minus T final. We already got the ratio of SC equals to SA. So the final temperature will be coming as 20.2 degrees Celsius. Guys, are we clear with this mixing of more than two liquids? All of you, are we clear with this particular question? As I said, this was repeated in JEE Mains, I think recently, 1 or 2 years back. But I'm sure now all of you are comfortable with these kind of problems. Shall we move ahead and take a different type of problem? Okay. And after this class, I will give some questions similar to this for practice. Please go through those questions before next class. All right. So till now we have solved the questions where specific heat was constant. My point is, what if specific heat is variable? Then what we will do? In that case, if specific heat is a function of T or it's variable, in that case, heat will be written as M function of T into dt and integration from initial temperature to final temperature. Is that point clear to all of you?
So here small t is time, right?
No, beta, it's temperature.
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 Okay.
Time has no role here in this topic.
Okay.
Is that clear to all of you?
So could you repeat once?
Yeah, sure. What I said is, if my specific heat is a function of temperature, this means function of temperature, right? T is temperature. Then I can't directly multiply specific heat with delta T. So what I will do, I will multiply mass function of specific heat, which is a function of temperature, with dt, and I will integrate it from lower limit initial temperature to final temperature.
Okay, sir.
All right. Let me take one question. Is this question clear to all of you?
Yes, sir.
Yes.
Please.
Sir, here we will substitute the temperature in specific heat, no?
Yeah. You can also take in kilojoule per kg if you want, because both are same thing only. Joule per gram and kilojoule per kg, same thing.
So, but for kilojoule per, like for joule per gram, don't we need to convert the mass?
Beta, what I'm saying is, if you're converting the mass, you will get final answer in joule, right?
Yes, yes, sir.
If you're not converting, then you will get the final answer in kilojoule.
Okay.
So based on that, you can give an answer. Avesh, it seems fine. Isabel, your answers also seems fine.
So like we will use integration here.
Yeah, because it's variable. So what we will do, we will put this as a function. Let me just write the basic equation. Have you used the integration or you directly put the value of t?
So I have used integration
Then fine.
as it is changing from 20 to 40 na?
Yeah. So we will write like this. Q equals to mass is constant, so you can take mass out. This is the function of we want to integrate, na? And it should come in kilojoule since I am putting the mass in kg. Is this clear to everyone what I have written over here?
Yes, sir.
All of you, Shri, Aditya, Arinja, clear, Gorangi clear?
Yes, ma'am. Yes, sir.
Yes, sir.
Yes, sir.
Konika,
Yes.
Pavni, Isabel, clear, beta? Yuvraj, Himanshu,
Yes, sir.
just integrate
Yes,
it and
sir.
tell me the answer. Others also, please send the answer. She just checked it is 1, 2 or 1, 4.
So
That-
just 1 second, I'm checking because I think that 2000 that I've taken.
Yeah, just check that. Gorangi seems fine.
Sir, the answer which I have sent to you is I have calculated it in gram.
Yeah, I got it. It's joule, na? So correct. That's not an issue. I understand by seeing the values. Aditya, correct, beta. What I will get from this will be 30 less because I have already converted in kilojoule. It's a simple integration. Okay, one last minute I'm giving because there are many who are on the verge of getting the answer. So please try to get it. Equation is in front of you, just have to integrate it. So here, what we will do is Q equals to 2. This integration thing, we can take both functions as separately. 2 is common, so I'll take it out. Here I will write t dt, and here I will write 5 into dt. Limit is same for both, 20 to 40. Okay. Here 2 t square by 2. So directly I'm writing 40 square minus 20 square divided by 2 plus 5. 40 minus 20, directly 20. Okay. So this part is clear to everyone. Shri, correct, beta. And I think when you solve it, you'll get 1400 kilojoules. That's the answer. Everyone, please give me a thumbs up if you are clear with this variable specific heat problems. Jitesh, Abhijay, clear?
Yes.
Okay. Konika, clear, beta?
Yes, sir.
Okay, good. All right, let us now move to a different topic. So now I'll come to that latent part because I want to do the whole calculation. This specific heat thing is clear. Mixing problems are clear. So as I said, there are two things that we have to take care. One is called latent heat of fusion, which I represent by LF. Now, here's the thing. When you have ice at 0 degree and you're giving heat, how much heat is required to melt the ice? It is mass into latent heat of fusion. This is the heat required to melt the ice. Is that part clear to all of you?
Yes, sir.
And similarly, latent heat of vaporization is there. So if we have a water at 100 degree and we are providing heat, so same logic, how much heat we want? Mass into latent heat of vaporization, right? So these are the two formulas for latent heat, and for change in temperature, so we already know that what is the value we have to take. Now guys, these value of latent heat of fusion and vaporization will be given in the question, but for our reference, we will take like this. 80 calorie per gram latent heat of fusion and vaporization is 540 calorie per gram. I have a question for you all. It's a conceptual question. I want you all to just read about it and come prepared with your answer in the next class. Right now, I don't want the answer. You see the value of latent heat of fusion and vaporization I have given to you. In fusion, what we are doing, we are melting the ice. So solid is becoming liquid. And in vaporization, what I'm doing, I'm vaporizing or boiling the water. So water is converting into steam. Ideally, to convert solid into liquid, we should require more heat. And to convert liquid into water, vapor, we should require lesser heat. But in case of water, it's very interesting that for vaporization, we are requiring quite a high amount of heat per gram as compared to melting of ice. So I want all of you to please think about the reason for that. Why melting of ice requires lesser amount of heat as compared to vaporization of water. Is my question clear to all of you?
Yes, sir.
Yes, sir.
Right?
Yes.
Because look, calculation we are doing, questions we are doing, JEE questions, advanced question, everything we'll do. Ultimately, what is important is to understand the concept. So these values makes there are some reason for behind this, right? It's not like randomly we have written over here. So I want as a student, you should know each and every part of the things which you are doing. So please go about these, try to get the answer for this question in the next class. When I will start, I will ask this. Clear? So now let's start doing the questions. So any mass of ice at 0 degree, how much heat you want? 80 calorie into mass. At 100 degree, how much heat you have to give to boil the water? 450 calorie into mass. Obviously, when you're using calorie, you have to keep the mass in gram. And later, if you want to give the answer in joule, you have to convert it. Are we clear with this?
Yes.
Yes.
Yes, sir.
Okay. Here is a graph I'm drawing. based on, suppose I have ice. Suppose we have ice at minus 10 degrees Celsius, and we want to convert into steam at 100 degrees Celsius. So this graph is about the temperature versus time. Now, can you just think about how the graph will look like? I'll draw it here. Just let me know whether you are comfortable with the graph or not. First and foremost, the temperature will rise up to how much? From
0 degrees Celsius.
0 degrees Celsius. At 0 degrees Celsius, the rise will continue or it will stop for a time being.
It will
Stop and the line will
it
be
will stop
straight.
and it will convert to water first.
Yes. So this process represent what, girls? Sorry, everyone. This represent
Melting of ice at 0 degrees Celsius.
melting, right? And once we are done with this melting, again the rise will continue. And it will go up to which temperature? Obviously, it will go up to 100 degrees Celsius. And at 100 degrees Celsius, this thing will again go and it will represent what? You can call it boiling or it can call it vaporization. Same. So since we have to draw only till 100 degree, I'm stopping it here. You can further extrapolate to more higher temperature. Are we clear with this graph? Everyone?
Yes, sir.
Yes.
Makes sense, no? So we will do a lot of question based on that. But as of now, I want all of you to get comfortable with the calculation of how much heat involved when ice melt into water and water rises and go up to a certain temperature and it boils. Okay, so I'll just give one question. Yeah. Anyone
does
asking
the-
anything?
Sir, does the melting part also shows that it is the latent heat of fusion?
Yeah. Actually, you can get the latent heat of fusion. How? Because if somehow they give you rate of heat, right? Let's say Q, how many joules per second you are providing, if they gave you, and this time you know, right? And the mass is known to you. So you can get heat as Q into T. This is the heat given, right? And once you get the heat given, it will be equals to mass into latent heat of fusion. Is that clear, Pavneet?
Yes, sir.
So I said now I will come to this graph and we will do a lot of questions because in JEE they try to get the questions from the graph. So as a student, you should be comfortable with this. But I just introduced the graph to make you understand how we draw the temperatures
Sir.
when the different processes are going on. So all of you, if my ice have a mass m or m naught, Shri, you want to ask something?
Yes, sir. Sir, could you please give the values in joule also? Means if we want to calculate, sometimes the other values are in joules.
You want the value latent heat of vaporization?
Yes,
User?
vaporization.
Yeah, sure. Why not? You can do it by yourself also. 336, let me write it here. Latent heat of fusion. Everyone please write if you want. 336 joule per gram. Or you can convert into kilojoule per kg also, right? Both are same thing. And vaporization will become 2268. I'll tell you one thing, and I'm keep repeating it. In JEE mains or JEE advanced question, these value will be mentioned in the question itself. So you don't have to worry about it. It's not something that you have to remember. Is that clear? For our question, maybe if not given, so we will have these values, so we'll take the reference. This is what you wanted, Shri?
Yes, sir. Yes. Thank you, sir.
Okay. All right. I was going to gave one formula. Okay, guys, just one simple thing, then we'll move to the calculation part. We have ice. I just want formulas. At -10, mass is m naught, specific heat, and one more thing, specific heat of ice and specific heat of water are different. And as a matter of fact, let us write it down that also. Specific heat of ice and specific heat of steam both are half calorie per gram per degree Celsius, or in joule if you want, 2.1 joule gram per degree Celsius or Kelvin. So please mention that. I don't want any one of you to think that the specific heat will be same. Okay. So what I was asking is, we have ice and we want to convert into steam at 100 degree. So we want to calculate the total heat required. So I'm just writing the formula. Please let me know whether we are comfortable with this or not. First, this ice will go. Himanshu, please try to avoid not writing anything on the whiteboard.
Sir, what is written here?
Acha, this one.
Yes, sir.
M not. Okay. Sorry, I thought that by mistake you have written something. First, the ice will rise up to what temperature, guys? 0 degree. So how much heat we will require for that? Mass of ice, specific heat of ice, 0 minus -10. Is that clear to all of you? That this much heat we have to give to rise the temperature of ice from -10 degree to 0 degree? Everyone, are we clear?
Yes.
Okay, at 0 degree, we all know what is going to happen. At 0 degree, it will be m naught into latent heat of fusion. Then all the water will convert. Since I have a small space, so I'm writing like this. Wait. All the ice will convert into water, 0 degree. Now this water will rise up to 100 degree. So how much extra heat we require? M naught into specific heat of water into 100. And finally, at 100 degree, all the water will convert into vapor. So it is latent heat of vaporization. So these 1, 2, 3, 4. These 4 heat what I have written over here is clear to all of you.
Yes, sir.
Yes, sir.
So what did you write for Q3 after
Beta, this is mass into specific heat of water into 100. That's the rise of the
oh, okay.
anytime if something written on the whiteboard and it's not clear, because I'm also using the pen tablet. So sometime when I'm writing something, it's quite high possibility that you may not able to understand. So immediately ask. Okay. So Gaurangi, clear?
Yes, sir.
Okay. So shall we proceed with the numerical now?
Yes, sir.
Yes, sir.
Yeah, just one sec. Here is the question 22.1. All of you quickly just go through it. I have already told you about the process, so you don't have to think too much. Just calculate and send me the value.
Sir, which one? 22.1.
22.1. Is it visible?
Yes.
Okay. 8 gram of ice at -15. You can give me your answer in calorie only. You don't have to convert into. Isabel, correct, beta? Yes, correct. Good. She correct, beta. I'm giving 2 minutes. Others also, please quickly finish it. Uh, Yuvraj, correct. Arinja, correct. Himanshu, correct. All right. Gaurangi, correct, beta. Good. Pavneet, yeah, correct. Slightly more than what it should be, but fine. It's near. Aditya, correct. All right. So I think most of you got the answer. So here, formula is already written. Mass, if we have to take total heat, it should be, how much was the mass?
8
8
grams.
grams. Okay, so 8 into 0.53 from -15. So we are coming. So this is our Q1. Then 8 into, that was a 80 only, no? 8 into 80 plus 8 into 1 into 100. And the last will be 8 into, I think 539 they have given. I had told 540. Anyway, so total, I think 5815.6 calorie. If you're getting somewhere slightly more or less than this, still it's fine. That's why I told it's correct. Are we clear now with these kind of problems?
Sir, instead of 539, I took the value 540 for that.
Yeah, sure. That's why some of you have given me answer like 5812 or 110. So it's totally fine. We know we should understand how we are writing this. These one value here and there will not going to make any difference. Okay. Now here comes a good question. Follow-up question. Let me share it here only. You have to plot a graph of time versus temperature versus time if you are providing 10 calorie per minute. Okay. So please try to draw the graph. We already seen how the graph should look like. Let me explain you a bit what is the meaning of graph. Suppose this is 8 into 0.53 into 15. So this value, if you calculated, it should have come out like 63.6. How many calories per minute you are giving? 10 calories. So for this, T1 time will become 63.6 divided by 10. So 6.36 minutes. Is that part clear to all of you? Is this clear what I have done here?
Sir, could you repeat
Please
once,
explain this
please?
again.
Yeah, sure. What I said is For ice to come from -15 to 0, this much is heat required, na?
Yes, sir.
How much is this? 63.6. In question second, it is given that 10 calorie per minute we are giving. So for 63.6 calorie, how much time we have to spend? 63.6 divided by 10. So 6.36 minute, right?
Yes.
Now,
Yes.
when you plot the graph, your graph will look like this something. It should start from -15. This is temperature. So here you will write, here you will draw -15 degree, and it will go up to 0 degree. So what you will plot here? You will plot, because this is the time axis, na? So here you will plot. You got the point?
Yes, sir.
Same way, how much time it should take for melting, you can calculate by this heat. And then I think this is more easy to calculate. This is 640. So T2 time will come 640 by 10. So how much we have to spend here? 64 minutes, right? So up to what time melting will take place?
Around 70 minutes.
70.3.
This plus 64, so 70.36.
70.3.
Are you getting, all of you are getting my point? What if they ask the graph question? Should we know how to plot it? So I have done two part. Ice from -15 degree to 0 and melting. Can you do the boiling of water and vaporization?
Yes, sir.
Yeah, do it. Now I know you can't send me the graph. You can send me the times so that I can understand in what time it will reach to 100 degree and what time it will vaporize completely. Those two times. Aditya, correct, beta. Shri, correct. Good. Yash, I think you have not added the time. You send me the time, how much it will take. I said the final time on x-axis. Just add it. Aditya, yeah, fine. You also missed the last one. Gaurav,
Sir, I
correct.
typed the wrong number.
Now the final answer of yours is correct.
Yeah.
Abhijay, just check your answer. Yuvraj, please add the time. Pavni, who's this? Ishan. Beta, please try to send the answer in private message. And your answer is fine, but please add the time 70. Yes, correct. Now listen, just by looking at the answers, I can understand that you all have got the answer correct. This will take further 80 minutes for reaching up to 100 degree. Now 80 minute plus 70.36 will make it 150.36. That is what I wanted. Okay, so this part is 80, which some of you have sent. I'm sure you got the point. And afterwards, it will boil. So for boiling, obviously I can extend the graph a bit more. So for boiling, it's taking 431 minute. So this much time it take for boiling. And we have 150, so final answer should come. Is this clear to all of you? The plotting of the graph, because most of you have sent me the same answer. So guys, please give me a thumbs up if you are clear with this concept of both the calculation part as well as the plotting of the graph part. Okay, good. All right. We'll stick. Now, slightly I'm going to raise the level. Okay. Till now, things what we have discussed was important, but it was not that difficult. But now I'm going to slightly raise the level. Suppose m gram of ice at 0 degree mixed with 2 kg of water at 40 degrees Celsius. Find m if final temperature is 30 degrees Celsius. Specific heat of water, you can take it as 1 calorie per gram degree Celsius. Latent heat of fusion, you can take it as 80 calorie per gram. Please try out this question.
What is the specific heat capacity for ice?
Why you want that? It's 0.5, but it doesn't require here. because ice is already at 0. It's 0.5 calorie per gram per degree Celsius. Okay. Shri Himanshu Gorangi, I have just made up this question, so I have to check the answer. Okay, so just wait for 2 minutes, then I will give the solution. Okay, many of you are getting the similar answer, so I hope that answer is fine. Aditya, no, beta, that is too much. Okay, let me just explain this question, right? And I'm hoping that the common answer which I got should be the answer which is correct. Yuvraj, many of the students are getting the answer in that range only. So just wait for a minute. Okay, here, what is the logic and how we're going to proceed such question? Water is receiving heat. So initial temperature is 40. Sorry, ice is receiving heat and water is losing heat. So heat loss by water. Heat loss by water will be how much? It will be 2 into 1 into 10. So this is how much? 20 kilocalorie. Now guys, I'm using mass in kg, so I'm deliberately keeping kilocalorie per kg. Is that fine to all of you? What I have written over here? So those who have written mass in gram, don't get confused. We all are doing same thing. Okay. Now, obviously, whatever heat is lost by water, it is gained by ice. So to ice has to come from 0 degree first. What will happen? Ice will melt. So first ice will convert into water, and then from 0 degree, it will come up to 30 degree. So basically we need to get these two heat, Q1 and Q2, right? How much ice is getting? 20 kilocalorie. So Q1 is mass into 80 plus it's kilocalorie, so I'm taking mass in kg. And second is M130. That all should be equals to 20. So if we add this 1110 M equals to 20. We are getting 2 by 11 kg. Okay, so most of the students who have sent me the answer, they have sent this answer only, which is 1.181 point or 181 gram approximately. 181.8 gram. Guys, are we clear with this? All of
Yes,
you?
sir.
Everyone, please give me a thumbs up if we are clear with this, or if you have any doubt, you can clear it. And I'm talking to all of you, not only few. All of you should be clear with this question. Aditya, clear, beta?
Yeah, sir. Yeah.
Okay. Ishan, Jitesh, Yuvraj, clear. Grishma, clear.
Please explain this question once again.
What, Abhijay?
Can you explain this question once again?
Yeah, sure, beta. Could you please mute yourself so that it will be clearly audible to you? Abhijay, what logic we have used here is that since we are mixing ice with the water at 40 degree, so obviously ice being at lower temperature will get the heat, and water being at higher temperature will lose the heat. And since no heat is going out, so whatever water will lose, ice will receive. So first we have calculated how much heat is lost by the water. So since the water initial temperature was 40 and it is coming down to 30, so heat lost by the water is mass specific heat into drop in temperature, that is 20 kilocalorie. Since I have used kg, so I have used kilocalorie as the unit. Now here for ice, first it will melt, so it will require some heat. How much heat? Mass into latent heat of fusion. Then after ice melt completely in water, it is not only stopping at 0 degree, it is rising up to 30 degree because that is the final temperature. So for that extra, how much heat is required? Mass into specific heat into 30. And since we are both sides should have same unit, so I have kept mass in kg. So we compared heat lost and heat gain, and we got 2 by 11, which in fraction, in decimal, it will be 0.181. Is that clear to you?
Can I
Abhijay,
understand why did we equate it to 20?
because from where ice will get the heat? If you mix ice with water, from where ice will get the heat? Tell me. If water is at 40 degree, it's the water who's losing the heat. Now it's coming down to 30 degree, right? And since we are mixing it in calorimeter, there is no extra heat given or no heat is lost. So whatever water will lose while coming down from 40 to 30 will be received by the ice. Did you understand the logic why we have compared this?
Yes, sir.
Okay. All right, everyone. So let's now take one more question. Just one sec. I'm sharing the question with you all. All of you go for question number 7 first. Can you see question number 7, everyone?
Yes, sir.
Go for it. Isabel, correct, beta. Good. Isabel, you can try question number 6.
Okay, sir.
Shri, correct, beta. Go for question number 6. Gaurangi, correct. Good. Aditya, correct, beta. Go for question number 6. And here data is not given in question number 6, so you can use the data which I already told you guys to do. Aradhya, correct. Arinjya, correct. Good. Okay, most of you have already sent the answer to me, but there are few who are still I think didn't get the answer. So let me just take the first question. So the first question says that we have three liquid PQR. Four kg of P at 60 degree mixed with 1 kg of R at 50 degree. Resultant is 55. So we can get the first equation from here. 4 specific heat of P, 55 minus 60 plus 1 into specific heat of R into 55 minus 50 equals to 0. So we'll get 4 times of specific heat of P equals to specific heat of R. Right? And 1 kg of P at 60, 1 kg of Q at 50. 1 kg of P at 60 and 1 kg of P at 50. Mixed, they get 55. So here we can directly say SP equals to SQ. Right. So obviously they are asking when 1 kg of Q at 60 mixed with 1 kg of R at 50, what will be the final temperature? So 1 kg of Q plus 1 kg of R equals to 0. Here SQ equals to SP, which is 1 by 4 of R. She, I think your second answer is also correct. So we'll put this as SR by 4 T final minus 60 equals to SR 50 minus T final. This and this will get cancelled. So I think T final here will get as 52 degrees Celsius. Is that part clear to all of you?
Yes, sir.
Isabel, correct, beta. Those who didn't give me the answer, are we clear with this?
Yes, sir.
Okay.
Sir, can
Aditya,
we
you want to
discuss the
ask
sixth
something?
one?
Sorry?
Can we discuss the sixth one? I'm not getting the answer.
For sixth one, you have to take 15 gram of ice is mixed with 10 gram of water at 40, right? So if you bring down the water to 0 degree, whatever is heat required, more than that heat, the ice will absorb. Okay.
Yeah.
So I'll just explain the sixth one. You try it in the next class. We're gonna take from here onwards, right? So how much mass of water is given to us? 10 gram, right? So again, we use the same logic, heat loss by water. So I'm going to check here whether the water, if it is coming down to 0 degree, how much heat it will lose. So from where to where it is coming down? 40 to 0. So the heat lost by water is how much? 10 into 1 into
40,
so 400 calories,
400.
isn't it? Suppose ice require more than 400 to melt. That means the final temperature will be 0. Means water is not sufficient enough to melt the ice. If ice melts down completely and still we have some heat left, then the temperature will rise. Is my point clear to you?
Yes.
So let us see how much ice required. How much mass of ice is given? Heat required by ice to melt. So ice mass is 15 and each gram requires 80. So how much this will come?
So
1200.
It will be 1200 calorie. So are you getting the point that heat required to melt is more than heat loss by water? That means even if water dropped to 0, it will not able to melt all the ice. So what will be the final temperature? Is this clear to all of you? The sixth one. All of you, is this point clear?
Yes.
So please explain this last portion of this question.
Yeah, sure, beta. Actually, sometime it requires maybe few explanation, but eventually you will understand. What I said is water maximum heat it can lose by coming down to 0. So this is the maximum it can lose. And for ice to melt completely, 15 gram of ice to melt completely, it required 1200 calorie. So if the water have 1200 calorie, all the ice will melt. If water have more than 1200 calorie, then the final temperature will be more than 0 degree. But here the maximum water can lose is 400, and what ice requires to melt completely 1200. So obviously the requirement is more than what is water is giving. So that's why the temperature won't able to rise. Partial amount of ice will melt. Abhijay, is this part clear to you? Guys, although they have not asked this part, but I'm giving you as a homework question. It's very simple. Can you tell me what mass of ice is melted? Not all.
that is there in the second part.
It's there.
The one that you
Sir,
gave
we
us
have
the
to
question, the
find
second part is there.
Acha,
how
we
much
have to
ice,
find the
how much ice and how
okay,
much water is there. We should.
okay, composition they have asked for it. I didn't saw, I saw only temperature. Acha, the final mass. Okay, fine. That means that's there. So what we can do for that question is how much heat ice is getting? 400 calorie, right? 400 calories. So the mass of ice melt will be
5 gram, right?
yeah, sure, 5 gram. Because 1 gram requires 80 calorie, so 5 gram will require 400 calorie. So final composition will have 15 gram of water, I think, and 10 gram of ice. Is that clear to all of you?
Yes.
All right, everyone. I hope whatever we have learned today is clear to all of you. Whatever question we have done is clear. I will send some questions for practice in the PDF. Please go through those questions before the next class. Okay. Thanks for joining. See you in the next class. Bye-bye. Take care, everyone.
Thank you so much.
Thank you, sir.
Bye.
Good night.